All right. Good morning, everyone. Welcome back to this week's episode of Pulumi TV. My name is Luke Hoban, and today I'm going to be talking a little bit about what's new in Pulumi. So it's hard to believe we launched Pulumi publicly just about 6 weeks ago, I think. So it's really only been about a month and a half. But we've already seen a lot of exciting new things be delivered in the time since then, both things that we've been doing ourselves on the Pulumi team, but also some great things from folks in the community who have been building interesting projects and contributing things on top of the core Pulumi project. And so today I wanted to spend a little bit of time kind of highlighting a few of those things and using it as a chance to kind of go over some of the areas that Pulumi is expanding in and will be expanding in further over the coming weeks and months. So as always, for those who kind of haven't joined us before here, you can get started with Pulumi at pulumi.io, and so all the information to get installed, to get started, to download the tools, and to learn about how you can apply Pulumi in the various domains that you might be working in are all here. And so I encourage you, if you haven't yet downloaded and tried out Pulumi, go ahead and do that. And also go ahead and join us on our Slack channel. A lot of the community contributions I'm going to be talking about today are things which we worked with folks in the community Slack channel on helping them to build those out and to figure out where we'd take them and host them and that kind of thing going forward. So definitely encourage anyone interested in sort of learning more and getting engaged with Pulumi to jump into our Slack channel and join us there. Okay, so let me go back and let's talk about a few of the things which are new. So there's 5 or so things I wanted to kind of cover quickly in today's live stream. So the first one, when we launched, we had support for AWS, Azure, Google Cloud, and Kubernetes. We had a little bit more feature richness in some of those than others, but we had the fundamental support for all those platforms. We're both working on sort of increasing our level of richness on top of some of those platforms, but also expanding the number of platforms that we can target. And one of those was a contribution from a user named Fraser who wanted to use Pulumi with OpenStack, and so contributed the support for OpenStack. And we've gone ahead and taken the work that he did, expanded on it, and we're going to be making that available publicly very soon, but you can already start using it in Fraser's fork. And so I'll show a little bit about how you can use Pulumi with OpenStack in just a second. We also, when we shipped about 6 weeks ago, had support for Google Cloud, but using Google Cloud functions, in the raw way is fairly difficult, like it is with AWS and like it is with Azure. And so, in the same way that for Azure and AWS, we really wanted to make it much easier to use Cloud Functions to hook them up to events. We're working on that with Google Cloud as well, and thanks to some work from Mikhail Shilkov, we're integrating that into our core libraries for Google, so that it's much easier to work with functions and to really hook them up in a lightweight way that Pulumi can be really great at. For folks doing sort of core AWS infrastructure, which has been one of the big areas we've seen a lot of folks applying Pulumi, the same kind of projects that they have previously been doing in CloudFormation or in Terraform or tools like that. One of the users, James Nugent, contributed some really great packages on top of the core AWS building blocks that we provide to make it really easy to spin up a VPC or do a few other things. And so I want to highlight a few of the packages that he built and go and look at some of the details about how he did that. We also simplified our support for containers even more. So for folks kind of trying to spin up a lightweight container, this is another area. We saw a lot of folks have come and looked at the tool and gone and wanted to use it to just stand up a few containers in a production environment inside AWS or Azure. We've simplified that model even more, and I just want to show that really briefly. And then probably one of the biggest things has just been the set of content, the number of examples and blog posts and things that we've put out that kind of highlight the variety of different ways you can apply Pulumi. And so I just want to quickly show off a few of those things as well. So with that, let me dive in and start showing a little bit of code here. So let me start with the OpenStack support. And I'll come over here into our Pulumi OpenStack repository. And this is based on the repository that Fraser did on GitHub. We are now in the process of working with him to take that over and make it an official project in the Pulumi organization. And so our version of that will be public shortly, probably later this week. But let me give a little preview of kind of what you can do with this. So this is an example of using the Pulumi OpenStack library. And like with all of our core cloud providers, this is a way of projecting all the capabilities of that provider into the programming model, so you can now code against them using a general purpose programming language. And so in this case, we're using TypeScript, but just like with all our other providers, you can work with this OpenStack provider using Python or Go or JavaScript or TypeScript or any of the languages that we'll support in the future. So one of the nice things, of course, with any of these libraries is that we can get sort of all the tooling benefits we expect. So we can get completion lists, and we can see that, hey, here I can do, OpenStack block storage, and I can see that I have a variety of different volume kinds that are available within the OpenStack APIs. I can do, OpenStack.database and create a database and a user and a configuration, and all these things that I might expect, again, from any OpenStack environment. And so in this particular case, I am just newing up an instance running Ubuntu 16.04, and then I'm going to export the IP address. Once this instance is stood up, it will have a public IP address, and we'll stand that up. And so I can come over here into my console and do what I normally do with a Pulumi program. I can look at what stacks I have available for this. And we see I just have one stack. I last updated it 9 minutes ago, but it has 0 resources because I cleaned it up before doing a quick demo here. And so I can come over here and say Pulumi update. When I do a Pulumi update, since there's no resources and since my program expects there to be this one instance, let me just recompile this. So we'll see that when we do the Pulumi update, as we expect from Pulumi, we get this preview telling us what changes we're going to make, and we see effectively we're just going to create that one instance. And so I can go ahead and say yes. I can go ahead and look at the details if I want and see all the details of what we're going to create there. Go ahead and say yes, and we'll go and provision this instance in OpenStack. So let me just talk for a second a bit more about OpenStack. So OpenStack OpenStack is a sort of cloud platform API that is available from many different vendors, and so you can use the same API for and the same provider from within Pulumi to target a variety of different vendors and host platform providers who are compatible with that API. And so, for example, if you want to target Rackspace, if you want to target OVH, there's a whole bunch of different folks who offer compatible APIs with this. And so this, having support for OpenStack means there's a wide variety of different platforms that you can now target from Pulumi as well. And so if you're not targeting AWS, if you're using one of these other platform providers as a cloud backend that does support the OpenStack API, you're now able to bring all of the tools from Pulumi to that cloud environment as well. And so this is a really nice thing to have available. It's also available from a number of on-premise providers. And so if you have an on-premise data center with the support, you can access that using Pulumi. So we now have support for this, and let me come over and see if this is done. So we created that instance. It has this IP address, and just like normal, we can kind of come over here and see that stack in the Pulumi console. So we can see the information about where it was deployed. We can see its IPv4 and IPv6 address, the image ID that it got installed, the network that was used to run this. And then we can also see the resources. So in this case, it's just this one resource inside this deployed program. But we can get all of the sort of same richness of managing these things for OpenStack as well. Now, in this particular case, I'm deploying to OVH. And so we can come in here and see in my OVH console, I've got this instance running here. And actually, let me refresh because I might have a different one running now. Okay, so we've got this test instance running, and you can see a few things. So one, in the OVH console, for example, if you want to use the OpenStack support, I can come over here and I can download the OpenStack configuration files, and these can be used really easily to set up your configuration, your environment variables, so that you can do Pulumi deployment. So nothing's really needed other than just downloading one of these configuration files and sourcing it into your environment. But now I can use that to spin up things like this VM here, and you see that just in about 45 seconds I spun up a VM inside OVH. Of course, if I try to SSH into this, well, that's because I did connect to this earlier. But yeah, if I SSH, this is not actually serving anything because this is not exposed on a public endpoint. And so let me just come in here and put back in some code I wrote earlier that highlights how we can do this. So I'm going to add two things in here for this particular instance. I'm going to, as well as the instance down here, I'm going to add a key pair, so an OpenStack compute key pair. And I'm going to add a security group with two rules associated with it for each of the two ports, 22 and 80. So for each of those, I'm going to allow ingress on TCP over IPv4 to that security group from that port. So for each of those port 22 and 80. So you see a few nice things from Pulumi here. So one is, of course, we can do things like loops and that kind of thing. We can factor this out in various ways. We also see we can just use node functions to read a file in if we want to. So in this case, I've got this file that has my my public key, and so I want to use that as the public key for the SSH key pair. I could provide this through config or a bunch of other sort of more robust mechanisms, but especially as I'm just bringing something up, it's very useful to be able to read this in and test it out quickly and iteratively. And so let me just come over here and compile that new code with those updates. Run Pulumi update. And we see as normal from Pulumi, we kind of see the kind of updates we expect. So that security group, the key pair, and the two security group roles we wanted to create are all going to get created. And then the instance is going to get replaced. And that's going to get replaced because we added a key pair, which requires replacement of the instance. And so if I go ahead and say yes, we'll go ahead and make those changes in the OpenStack provider. Okay, so we added all of those resources, and now we're just going to replace that instance. And we see even the details of what's going to change. The key pair and the security groups were added, and as a result of that, the name is going to have to change. So we're now replacing this instance. And in fact, if we come over here, we may be able to even see Pulumi actually does, by default, when it replaces things, it creates before it deletes. And so that means that we'll make sure that the new one is up and running correctly before we tear down the old one. This helps to prevent downtime. And so in this case, we see that the old one is running just fine, and the new one is still in creation. And so this will then become okay, and now we should start seeing this one delete. If I refresh again, it should be in deleting mode. I don't know if OVH updates, how quickly it updates the status of these things, but we should see it disappear in just a second. There we go. So it says it replaced. So there we go. Now we're back down to one instance running this thing. And if I then go and take this sort of thing and say SSH Ubuntu at we should be able to connect to this instance that we're running. Oh, I got the wrong IP address, didn't I? In fact, I can do SSH Ubuntu at Pulumi stack output instance IP. I misspelled it. Add that fingerprint, and now I should be inside my Ubuntu instance. So there we go. So easily able to then go and expose the right port so that I have access to my instance. Exit, and now I've showed off kind of using an OpenStack instance. And of course, everything else within OpenStack that you saw there is also available there. So if you want to access database services or whatever, we have the access to all of those. So for anyone using OpenStack against the variety of different OpenStack providers, this is a really handy thing to get access to the value of Pulumi, but against those environments as well. So let me move on and talk about the next thing, Google Cloud Functions. Functions is a key thing. Serverless applications are one of the environments where we've seen Pulumi really being valuable, because to build up serverless applications, you tend to need to compose together lots of little pieces. And that having those little pieces and having them be able to sort of version independently and be deployed very simply is one of the things people love about serverless. But because there's so many little pieces, it makes the development process actually where a lot of the challenges become. And that's where Pulumi can help, is to make it really easy to express and version and manage all these different functions. And so we wanted to bring all of that kind of benefit of Pulumi over to the Google Cloud space. And so let me switch over into our examples repo and show an example of using Google Cloud Functions. So here we have an example that just uses this HTTP function helper that we created. And so HTTP function is a new abstraction that you can use. Instead of using the raw capabilities provided by Google, you can just use HTTP function. And I'll show in a second what's underneath that. But that basically stitches together a few of the different building blocks you need to use to expose a function as an HTTP endpoint using Google Cloud Functions. And so in this case, you see I'm doing it in a very simple way. I'm just giving it a name, and then I'm giving it a callback. And this callback is the actual code that's going to run at runtime. So when this HTTP function gets hit, it's going to run this code and respond to the HTTP request. One of the really nice things with Google Cloud Functions is that the API it exposes is very strongly typed in a sense. So it's actually, you get a fully populated Express.js request and response object, and so those are very rich things to work with. Whereas in some of the other platforms, you just get a very custom, request object that isn't HTTP specific in some sense, and you kind of have to do a lot of the work to do the parsing of the data out of that. Here you get a real request object. You can use real Node.js Express libraries to work with that thing. And so here, for example, because we know that this request is a express.request, if I say .bdy, I get an error there. And I'm actually getting error checking both on the inside of my function and, of course, on the outside. So if I mistype one of these things. And so we get all those benefits of kind of the strong typing that Pulumi can provide, and we get to bring those into the runtime code you're authoring as well. In this case, we're just going to call this send function, which sends back a response, and we're just going to respond with a string, and then we're going to publish the URL. And so if I come over here, I can do the same thing I did before. Type Pulumi stack ls. We see that we have this one function here, and if I just do Pulumi update, we should be able to deploy this function, and I'm getting some warnings just because I have a build of this locally. But we see that when I want to go and deploy this, it's suggesting it's going to upload. It's going to create 3 objects in Google Cloud Platform as part of building up this HTTP function. So it's going to build that Google Cloud Functions function object, and then it's also going to create a bucket and a bucket object to store the source code for that object. So if I go ahead and say yes, I can go ahead and create that. Very quick to create these objects, and then the function takes maybe, I think it takes 10-20 seconds to create. But overall, very quick. And while I was waiting, well, let me just come over actually into the Google Cloud Functions console. And if I refresh this, you see here I'm logged into the Google Cloud Platform console. And you can see now this function that I'm creating has actually got the spinner here. It's actually in the process of being deployed. And so I can come over to this and watch it. We should see it in just a second. Oh, there we go. It has a green check mark, so it finished deploying. And so here we can see all the details about that Google Cloud function. See, it took about 30 seconds to deploy that. Just like before, we can get access to all the details about this over in the Pulumi console, including the list of resources and even the sort of resource view, which shows that we have that component that then has those 3 children as part of it. But back over here, I get this URL, and if I go to that URL, I actually get that string that I printed out. And just like with everything else in Pulumi, if I make some change to this and sort of say, hey, this is going to be Pulumi TV, compile that, and then update, we'll see here that Pulumi knows to make just the minimal changes it needs to. Oh, did I not save that? I don't know why we're not actually seeing an update there. But if I make some changes here, we would expect it to only show the changes that have actually need to be made as part of this particular update. So let me move on and show actually what's underneath the hood of this, because I think that shows kind of what a lot of the work that the folks who are contributing this, the work that Mikhail is doing on bringing this into our core library right now, what that work kind of looks like, and some of the building blocks that Pulumi offers to build this sort of thing if you want to go and extend this into your own platform as well. And so one of the things you'll notice for this HTTP function is it's a component resource. And so Pulumi has a notion of components, which is a way of describing these sort of custom combinations of resources. And these will show up as sort of nodes in the tree, or in that resource view that we saw here, they'll show as sort of nodes with children underneath them there. And so an easy way of sort of packaging up a set of functionality into one reusable component. And these are very handy because you can provide any API you want to users that wraps a whole bunch of interesting cloud behavior behind it. And so in this case, this HTTP function is one of these, and it just exposes off those constituent parts, the bucket object, and the function. Inside it does a few interesting things. So first, we have this underlying capability in Pulumi runtime to serialize a function. And this is how we turn that handler that the user wrote into a piece of code that can then be stored inside a Google Cloud function. And this is actually non-trivial. Folks think about just, oh, I'm just going to toString that function in JavaScript or something like that. We go quite a bit deeper here, and we actually capture all of the captured values. So if I had done something like let stir equals, I could write this, right? Now I have this free variable here that is captured from outside, but I can use that. And in fact, this is very useful when I create other resources inside my function. I want to reference them from within my function. And so maybe I create a database up here, and I want to just pass a handle to that thing in. And I don't want to have to swizzle it through an environment variable and deserialize that out of the environment variables. I just want a handle to that thing directly. And so we can do that sort of thing with this serialized function capability. We then use that to sort of build up the function text and the entry point information, and use those to create a bucket and a bucket object to store that. And the interesting thing is, because this is going to actually deploy every time we do an update, we're just going to see the deltas. Only because the function text change are we going to see that this bucket object needs to update. But the bucket itself will never need to change because there's no inputs to it which change over time. And so for as long as this component exists, we'll just have one bucket that's managing the objects that this gets stored in. And then finally create this underlying function pointing at that bucket and bucket object and using the entry point that we wanted to specify. In this case, so far we're supporting just HTTP, and so we're triggering that HTTP. As a next step, we're planning on supporting the sort of full range of other event sources that Google Cloud Platform provides. And so you see, it's very simple to write this kind of component that wraps up this behavior, but it's actually very important to be able to build these sort of things, because manually writing all of this every time you want to upload a function is quite cumbersome, and there's a lot of little details like the serialized function, the way that these bucket objects get constructed, that are very, you have to get just right to make sure that the behavior of the updates is correct. And so turning these kind of things into a component, making them easily available is a really nice thing, and really happy that Mikhail is working on turning this into a component that anyone can use. Okay, so that was Google Cloud Functions, which was really nice. The next one is sort of raw infrastructure and some of the things being built on top of that. So AWS infrastructure is sort of one of the places that a lot of folks are using Pulumi, and we, when we launched, we actually had a project, a package called @pulumi/aws-infra. Which was a set of building blocks for infrastructure. And they were fairly basic, useful, but fairly basic components for standing up a simple AWS network and standing up a simple ECS cluster. Since then, one of the users of Pulumi over the last few weeks has added a few of his own packages that do some similar things, but in a much richer way. And so these are really handy things to kind of build on top of. I'm going to highlight one of them here is this Pulumi AWS VPC. And this is a library for creating a very customizable AWS VPC, but using a high-level description of that VPC. And so in this case, you'll see here I can do vpc.create, and I can pass a whole bunch of different parameters. And James has documented here what all those parameters are. I can specify my CIDR space that I want to allocate to this VPC. I can decide how many AZs I want, whether I want a fixed number or I want one per. Sorry, how many subnets I want, whether I want one per AZ or that's available in the region, or I want to specify ahead of time a specific number. And then things like tagging all the resources automatically, automatically allocating a private hosted zone within the VPC, and potentially creating DynamoDB endpoints so that I can get VPC connections to Dynamo and S3, for example. So lots of rich capabilities to just with a single yes/no flag turn on a bunch of rich capabilities, which are actually somewhat difficult to do manually. And then ultimately, after you create that, you get access to the subnets, and the hosted zones, and what have you. And this is really interesting because that one little component, just with those few lines of code to create it, creates a whole bunch of resources, right? So a VPC ends up having lots of different pieces associated with it. For every AZ, I have to have a public and private subnet. I have to have these VPC endpoints. I'm going to have security groups and route tables associated with those things. I need an internet gateway so that I can access the internet. And manually hooking all these up is quite a bit of effort. And so what James's library here does is does all the heavy lifting for that and lets you just work at the much higher level of abstraction of I want this VPC with these particular characteristics. And so especially by publishing this as an open source component, this is something that he and others can then contribute to make richer if in places where people want additional extensibility. But it really should be no need to go and work for most folks at the level of these underlying resources. And so really excited to have this library available. And James has several other libraries that he has made and is making available. And so definitely encourage folks to check those out. Really good examples of AWS infrastructure being built with Pulumi. So for the sake of time, I'm going to skip over even simpler containers, and I'm just going to jump straight to new examples because I want to highlight a few of the things that we've added along the way. And there's sort of two things there that I want to talk about. So one actually that I think is really exciting, and I might even next week spend some time going through these in more detail. But for those of you who didn't check it out last week, Joe did a blog post on 12 Pulumi pearls. So these were just a bunch of little snippets of code that kind of gives you a sense of how you can use Pulumi in a bunch of different interesting areas. And so I think for folks kind of thinking about, excited about the idea of Pulumi, but trying to figure out kind of in which ways to apply it in which different domains and get some ideas for that, these are really good examples of a bunch of different quick looks at what Pulumi can look like solving a bunch of different things, from serverless tasks to container-based tasks to raw infrastructure, and then even just some general tips and tricks for interesting things you can do that are cross-cutting. And so lots of fun things to look at in here. Many of these are available inside our examples as well, but really focusing on some of the neat things about those in this blog post. So definitely suggest checking that out. But then with that, let me jump over to look at some of the other new examples. So I did talk about this GCP-TS functions. That's one that's new in the last few weeks. We did add this very simple example of using containers. I think this is super important. And since I mentioned that we have this even simpler containers, I should maybe spend a second on this. So the containers, we have a very simple way to stand up a containerized service. So new cloud.service, point at some folder with a Docker file, tell it what memory and what ports you want to expose and how many replicas, and now you've got that stood up on AWS. And in this case, by default, we're going to stand that up in Fargate. And so this is like probably about as simple of a way as you can imagine to get a Dockerized application running in Fargate. One of the nice things that we did recently, since it's very common, it's obviously important to be able to support services with multiple containers running inside them, but it's also very common to just want to run a single container. And one of the nice things, because we have a flexible API here, it means we can use all the techniques of API design to kind of overload things and let you customize the way you use this. And so we now support an even simpler model where if I have just a single container, I can just inline that. So I can say, hey, I want to run a service that is built from this folder with this memory, with these ports, and with 2 replicas. So about the least possible text you could write to express this application. Do a Pulumi update. A couple minutes later, you're going to have a load-balanced instance of Nginx running in AWS. And so I think that's very exciting in terms of using containers. We also have added a bunch of new Azure examples. So this is using Azure App Service. So this, when we talk to Azure customers, I'm always amazed at how many Azure customers are using App Service, especially since there really aren't moral equivalents of App Service in a lot of the other cloud platforms. And so this was a good example to kind of show off all the various pieces of that. And it uses a lot of different things from Azure, right? It uses storage accounts and storage containers. It uses app insights to create, to get visibility into what's going on. It uses a SQL Server as the backend database, and so we instantiate one of those and create that with the username and password that the user provides. And then ultimately we create that app service and parameterize it with some of that information. And there's lots of stuff going on here, but again, one of the key things with Pulumi is we can then go and wrap this all up, make it into a common component, make it really easy to hook all these things together. But for those folks using Azure and interested in the app service, this is an interesting example to look at. We've also done a bit of work on Python, and so we added a couple more examples of using Python. So one, for example, is here's an example of using Python with step functions. And so in this case, we're using Python, but we're actually creating a Lambda function from the code in this step hello folder. So just this little hello.py file. And then we're hooking that up into a state machine resource. So this will, in this case, we're just running one step, but we can run an arbitrary set of interesting steps with different gating between them using AWS's step functions. And so we've done a lot of work to sort of make this kind of thing work, support assets in Python, and other features to make the Python experience even better for those folks interested in using Python. So there's a lot more examples and a lot more coming. We have a EKS example that we're working on right now that is really exciting. One-click deployment of EKS, which is actually a somewhat complicated service to get stood up manually using the AWS docs today, and a bunch of other things that are new here that we'll highlight more in the coming weeks. Okay, yeah, so that's actually. I'll highlight really quickly is, AWS finally added support for queues as an event source for Lambda. And so we added this very simple example of using a queue, in this case an SQS queue, as an event source for subscribing to, and then you can run whatever code you want inside that. And so this is really nice. You can build a lot more interesting architectures in terms of your serverless apps now that you have the access to queues as well as to topics and timers and these sorts of resources. And this is something we added in our AWS serverless library, which is where we have all the kind of core serverless building blocks. And as well as adding this here, we've actually also started the work on the Azure serverless library. And so for folks trying to do similar things to this, but in Azure, that's work that we've started and is continuing to make progress on. So lots of fun stuff there. I'll probably leave it at that in terms of talking about examples, but we'll come back probably next week and spend some more time looking at some of these really interesting programming pearls that are available in Joe's blog post. So with that, let me just kind of wrap up for today. As I said before, if folks haven't yet gotten started with Pulumi, definitely encourage you to go to pulumi.io, install, get started, take a tour, look at the examples. Definitely come and join the Slack channel. Lots of great conversations going on there. Lots of folks helping to kind of answer questions and to give folks pointers on where to go to look for more information on getting started. Very happy that folks are liking the project on GitHub. We just passed 1,000 stars a few days ago. So thanks to everyone who's following us on GitHub and contributing to the project there. And if anyone is interested in following up on topics for future live streams, feel free to reach out to me on Twitter or in the community Slack channel. Thanks, and we'll see you again next week. Bye, everyone.